Welcome to The Explainer. Today, we're diving into a really fascinating breakthrough in physics. It's a new technique that lets us take crystal clear pictures of things that were, well, basically invisible before, by magnifying the quantum world from the inside out. Okay, let's just jump right in. On the left, you see the problem scientists have been wrestling with. They want to look at a system of ultra-cold atoms, but when they try to take a picture, all they get is this fuzzy, overlapping mess. But on the right, that's the goal. That's the dream, right? To see every single atom perfectly distinct. So the real question is, how do you get from that blur to that beautiful, sharp image? And this is the fundamental problem, really. For decades, this has been a huge roadblock for anyone trying to understand what's happening in the quantum world, on the tiniest scales. After all, you can't really study what you can't see. Now, to really appreciate how clever this new solution is, we first have to understand the wall that scientists were running into. It's a fundamental barrier in physics. It's called the optical resolution limit. And put simply, it means that if two atoms are closer together than about half the wavelength of the light you're using to look at them, your microscope just can't tell them apart. They just smush together into a single blob of light. So here's the crucial point. This isn't about just building a bigger, more powerful lens. We're literally hitting a wall that's defined by the nature of light itself. And for a lot of the most interesting quantum systems out there, the atoms are packed way, way too tightly to ever be seen clearly with the usual methods. And this is where a brilliant and, honestly, super elegant idea comes in from Salim Joachim and his research group over at Heidelberg University in Germany. They basically decided to stop trying to break through the wall and instead figure out a way to just walk around it. They completely flipped the problem on its head. They asked this really simple but totally revolutionary question. What if you didn't need a better microscope at all? What if, instead, you could just convince the atoms themselves to, spread out, to self-magnify before you even take the picture? And this number right here just shows how incredibly well it worked. The technique they came up with makes the entire quantum system expand uniformly, magnifying the distance between every single atom by a factor of more than 50. All of a sudden, what was impossible to see becomes, well, easy to see. So how in the world do you get a bunch of atoms to self-magnify? I know, it sounds a little like science fiction, but the method itself is so clever, and we can actually understand the basic idea with a surprisingly simple analogy. Okay, I want you to imagine a perfect swing at a playground, one with no friction at all. The physics that describes how it swings back and forth is almost identical to how these ultra-cold atoms behave when they're held in a special kind of trap, which physicists call a harmonic trap. It's basically a perfect energy bowl. So the whole process happens in 4 very precisely timed steps. First, they turn off any forces that are pushing the atoms around. Then, they let the atoms swing for exactly a quarter of an oscillation in a really tight, steep trap. Right when they get to the bottom of that swing, they instantly switch them to a much wider, shallower trap and let them fly outwards for a bit before snapping the picture. The real magic happens in that switch from the tight trap to the shallow one. It's like letting the swing go at the very bottom of its arc, but in that same instant, you make the chain on the swing much, much longer. The atoms fly outward, but, and this is the key, because of the special properties of that harmonic trap, they do it in a perfectly scaled way. The whole system just expands, just like you're zooming in on a digital map. And this right here is where we go from a simple classical picture to the really mind-bending quantum reality. This trick doesn't just magnify where the atoms are sitting. It scales up their entire quantum state, what's called their wave function. The final picture you get is a true magnified snapshot of the system's quantum soul, so to speak. Okay, so this is all incredibly cool, but what's the big deal? What new doors does this quantum magnifying glass actually open up for science? Well, this technique gives us access to some of the most exotic, most mysterious states of matter ever imagined. We're talking about things like supersolids, which are somehow a solid and a frictionless fluid at the exact same time, or these things called self-bound quantum droplets. In these systems, the particles are packed in so tightly, sometimes only 0.1 micrometers apart, which made them completely impossible to study until now. And really, this is the ultimate takeaway. We can now take that fuzzy, incomprehensible quantum mystery and turn it into a sharp, clear picture where you can see the position and state of every single atom. It's like going from being legally blind to having 20/20 vision when you're looking at the quantum world. An incredible new tool like this doesn't just help us answer old questions. It actually lets us ask entirely new ones we never could have thought of before. By giving us this clear window into these incredibly dense and complex systems, it really opens up a whole new frontier for exploring the fundamental nature of our universe, one atom at a time.